Hello everyone, my name is Anirudh Siddharthi. I am from Institute of Energy Engineering, Ernakulam branch. I am here to tell a topic about Laplace transform of impulsive function. Definition of Laplace transform. Let f of t be a given function of t defined for all t is greater than or equal to 0, then the Laplace transform of f of t denoted by L of f of t or f bar of s or capital F of s is defined as phi of s. So therefore L of f of t is equals to f bar of s equal to capital F of s equal to f bar phi of s equal to integral 0 to infinity e power minus st f of t dt, provided the integral exists where s is parameter real or complex. Laplace transform of impulsive function. The Laplace transform of impulsive function is a function that which exists only at t equal to 0 and it is 0. Uh, Elsewhere, the impulsive function is also called delta function. The unit impulse function is uh, denoted as del t. The amplitude of amplitude of impulsive function is infinitely large at t equal to 0, but the unit impulsive function that the area under the curve is equal to 1. The 1 in the figure 2.1 near arrow indicates the area under the pulse. Mathematically, it is represented as del of t equal to 0, t is not equal to 0. The area under the pulse is unitedly, that is, in integral minus infinity to infinity del of t dt is equals to 1. Impulsive function. The, in some application, it is necessary to deal with the phenomena of impulsive nature. For example, an electrical circuit or mechanical system subjects to a sudden voltage or force G of large magnitude that acts over a short time interval about t naught. The differential equation will then have the form a y double dash plus b y dash plus c y is equals to g of t, where g of t is big t naught minus t less than t less than t naught plus t, 0 otherwise, and tau is greater than 0 is small. Measuring impulse. In a mechanical system where G of T is a force, the total impulsive of the force is measured by the integral. I of tau is equals to integral minus infinity to infinity G of dt is equals to integral t naught minus tau t naught plus tau G of t is dt. Note that if G of t has the form G of t is equals to C 0 C t naught minus tau is less than t naught plus tau 0 otherwise, then I of tau is equals to integral minus infinity to infinity G of t dt is equals to integral t naught minus tau t naught plus tau G of t dt is equals to 2 tau, where r is tau is greater than 0. In particular, if C is equals to 1 by 2 by tau, then I of tau is equals to 1, independent of tau. Unit impulsive function. Suppose the force function d tau of t has the form d tau of t is equals to 1 by 2 of tau, that is minus tau less than t less than tau, 0 otherwise. Then we have seen I of tau is equals to 1. We are interested d tau of t acting over shorter and shorter time intervals. That is, tau is 0. See in the graph on the right. Note d tau gets taller and narrower. D tau gets taller and narrower as tau is going to become 0. Thus, for t is not equal to 0, we have limit tau extends to 0, d of tau t is equals to 0, and limit tau extends to 0, I of tau is equals to 1. Direct delta function. Thus, for t is not equal to 0, we have limit of tau is tends to 0, d of tau of t equal to 0, and limit tau extends to 0, I of tau is equals to 1. The unit impulsive function del is defined to have the property del of t equal to 0 for t is not equal to 0, and integral minus infinity to infinity dou of t dt equals to 1. The unit impulsive function of an example of a generalized function and is usually called the direct delta function. In general, for a unit impulse at an arbitrary point t naught, del of t minus t naught equal to 0 for t is not equal to t naught, and dou and integral minus infinity to infinity dou of t minus t naught into t dt is equals to 1. Laplace transform of del. The Laplace transform of del is defined by Laplace of del t minus t naught equal to limit tau extends to 0 L of d tau of t minus t naught d, t naught is greater than 0, and thus L Laplace of del of t minus t naught equal to limit del tends to 0 integral 0 to infinity e power minus st d tau of t minus t naught dt equal to limited tau extends to 0 1 by 2 tau integral t t naught minus tau t naught plus tau e power minus st dt equal to limit tau extends to 0 in into minus e power minus st by 2 tau. Uh, Limits are t naught minus tau t naught plus tau, which limit extends to 0 1 by 2s tau by 2s tau minus e power minus st naught plus tau plus e power minus s into t naught minus tau. Limit tau tends to 0 e power minus st naught by s tau into e power st minus e power minus s e power s tau minus e power minus s tau by 2 is equal to e power minus s naught to limit of s h s sine h s tau by s tau equal to e power minus s t naught into limit uh, tau tends to 0 s cos h sine s t s tau by s equal to e power minus s t naught. Laplace transform of del. Thus, Laplace transform of del is L Laplace of del of t minus t naught equal to e power minus s t naught. T naught is greater than 0. Find the Laplace transform of del at t naught equal to 0. Take limit as follows. Limit t naught tends to 0. L of tau of t of tau of t minus t naught. Limit at t naught extends to 0 e power minus s t naught equal to 0. For example, when t naught equal to 10, we will have Laplace transform of del t minus 10, that is e power minus 10s. Thank you, everyone.